Bismillahirrahmanirrahim. Assalamualaikum and hello everyone. Welcome to Unit 4 of FAST 5043. My lecture today will be discussing hazard rating determinations. In this unit, you will learn about what hazard rating determination is and also construct the hazard rating based on situations. Hazard ratings help us identify how harmful a chemical is to health. Let's explore how these ratings are determined. To assign a hazard ratings, chemical hazardous to health must be categorized into two groups based on systemic effects and local effects. Systemic effects involve internal damage through absorptions, while local effects happen at the point of contact, like skin or eyes. Step 1. Start by gathering information on hazard categories, risk factors, acute and chronic effects, and toxicity data like LD50 and LC50. Step 2. Use the appropriate tables to determine the rating based on either health effects or classifications. Then, rank the hazard rating from highest to lowest. Continuing from the previous steps, let's now assign a single hazard rating and address special cases. Step 4. Assign a single hazard rating based on the greatest degree of hazards. Group 1 includes chemical with severe health effects, ranging from very toxic to respiratory irritants. These are assigned higher priority. So, how do we assign a hazard rating to a chemical or mixture? Step 5. For chemicals falling under Group 2, assign an SK notations, indicating risk from skin or eye exposure. If a substance falls solely under Group 2 and not Group 1, the hazard rating should be based on Group 2 classifications. Refer to Table 4 and 5 for detailed rating methods, Table 4 for health effects, and Table 5 for risk factors under CPL regulations. Table 4 is used to determine hazard rating based on health effects and chemical toxicity. The scale ranges from 1 to 5, 1 being the least hazardous and 5 the most severe. A rating of 5 is assigned to chemicals that cause life-threatening effects from a single exposure or lead to irreversible damage, such as kidney necrosis or paralysis. These include non-human carcinogens, mutagens, and teratogens. Hazard rating 4 indicates permanent injury to skin or organs from repeated exposure. These may include probable human carcinogens based on animal data. Rating 3 includes serious but not permanent damage to skin, eyes, or mucous membranes. This may involve corrosive chemicals or harmful agents with moderate toxicity. At level 2, the effects are generally reversible, such as mild skin irritations or changes that resolve after exposure ends. Level 1 is assigned to substances with no human adverse health effects. These are not classified as hazardous. These tables determines hazard rating using risk factors or R factors, which describe the nature of chemical hazards. Hazard ratings are assigned based on the severity and routes of exposure, such as inhalations, dermal contacts, eye exposure, injections, or unspecified pathways. Chemicals with risk factors like R26 through R28 or R39 are considered very toxic, earning the highest hazard rating of 5. Toxic chemicals, such as those with risk factors of R23 to R25 or R48, receive a hazard rating of 4. Harmful chemicals, like those with risk factors R20, R22, or R40, are rated at hazard level 3. Corrosive chemicals that cause burns, like R34 and R35, are assigned ratings of 3 or 4. Irritants like R36 to R41 fall into lower range of 2 or 3. Sensitizers, those that trigger allergic responses, such as R42 and R43, are rated with a hazard level of 2. Chemicals linked to cancer, R45, R49, genetic mutations, R46, or birth defects, R47s, are rated between 3 and 5, depending on the level of supporting evidence. Let's go through a real examples of how to determine the hazards rating of a pure chemicals. Ethyl dimethylamine is harmful if inhaled or swallowed, identified by risk factors of R20 and R22, and also corrosive to skin, marked as R34. According to CPL regulations, corrosiveness poses a higher hazard than harmfulness. So, this chemical is classified as corrosive. For assessment, both harmful and corrosive effects must be considered under Group 1 and Group 2 hazard categories. A hazard rating of 3 is assigned from Group 1, and a SK notation is added due to skin corrosivity from Group 2. Even though skin exposure isn't assessed for hazard rating, it must still be controlled because of the SK notations. Now, let's examine how to determine the hazard rating for a chemical preparations. Preparation Z is made up of 20% benzenes, 50% xylenes, and 30% of non-hazardous substance. Based on its components, this preparation has been categorized as carcinogenic, toxic, harmful, and irritant. From Table 5, we can assign hazard ratings based on these classifications. Carcinogenic effects have the highest hazard rating of 5, which takes precedence. Thus, the hazard rating is assigned as 5. Exposure assessment must include all possible routes, and SK notation is added due to skin irritations. Let's walk through another examples, this time for a corrosive preparations. Preparation Y contains 45% sulfuric acid, a well-known corrosive substance, and 55% non-hazardous materials. It has been classified under risk phase R35, indicating it is corrosive to skin and eyes. According to Table 5, this places the substance under Group 2 with a hazard rating of 4. Therefore, preparations Y receive a hazard rating of 4. The exposure assessment only applies to skin and eye contact, since the substance is corrosive to these areas, and SK notation is required. In practice, this means strict control should be placed for skin and eye protections during handling. Next, let's look at the chemical preparations containing xylene and non-hazardous components. This preparation is made up of 30% xylene, which is harmful via inhalations and irritating to the skin. Based on risk factors, it's harmful by inhalations and skin contact, R20 and R21, and also a skin irritant, R38. According to Table 5, the classification is as follows. Group 1, harmful with a hazard rating of 3, and Group 2, irritant with a rating of 2. Therefore, assign a hazard rating of 3, assess exposure through inhalations and skin contact, and include the SK notation due to skin effects. Proper PPE like gloves and respiratory protections is essential when handling these preparations. Thank you for listening, and see you in the next unit.